Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're doing episode 2 of our reverse engineering Airbox. So in the first episode, we really focused on the basic shape, getting basically as close as we could without spending too much time. Now, there's always going to be a balance when you're doing something like this in Fusion, is figuring out how much time and effort you want to spend getting exactly the same part. Now, for a part like this, I know that the end goal from the user that sent this to me is to 3D print. I know that it's not going to be injection molded, and so we're going to take that into consideration when we're trying to recreate features. So there are certain features I mentioned in the last video, like these ribs and different features where we've got, openings or recesses to keep them thin-walled. The main idea behind this is based on injection molding best practices. So if you're looking for recreating something that's perfectly ready for injection molding, we are not going to be going down all of those different steps. We do have courses on our learneverythingaboutdesign.com website where we talk about those strategies for designing for injection molding and the considerations that you want. We will mention a few tips for things like keeping consistent wall thickness on certain parts, but most of these features, again, when we're talking about things like 3D printing, come down to the end goal, the material choices, the print orientation, and just understanding that this is going to be 3D printed. We don't need all of these extra little ribs here. We can put a large fillet or chamfer at the base of this corner, because with a 3D print, you can set the number of walls that you want to print or the number of traces around the walls, infill if you want it, and you can basically create a much stronger structure with 3D printing than you could with doing all these little ribs and features that you have to do for injection molding. So just keep that in mind. We're not going to go through the exact process to create this as an injection molded part. We're going to focus our attention on creating it as, in this case, a 3D printed part. In the last episode, we went through and we talked about different ways to use things like the intersection tool. We also went through the process of using features like press pull and split and move copy and loft. So that way we could create that body that was a really close approximation to this. Now, whenever I get sent scan data that I am able to share, I don't ever want to reveal the person's name. So anybody that wants to know how to get this data, I don't want people to get bugged by comments trying to get access to the scan data. So in many cases, when we get scan data like this that we are able to share, I still won't mention who sent it, just simply because I don't want to divulge that information. Now, if you sent the scan and you want to, sort of come clean and ask questions, like answer questions for people, that's totally your prerogative. That's fine. But for the most part, when we get these scans like this, I've had several that weren't able to share, and I get loads of emails, people asking for contact and they want to buy scans and things like that, and that's just not what we're going to be doing here. So this scan is provided. We went through the first episode where we created this body. If you had any difficulty or you want to pick up here, I'm going to put a link in the description to the version that we see on the screen that has the starting point solid body here. So I do strongly suggest, if you're trying to learn this kind of thing, that you start from scratch, but I understand that time is important and this stuff takes a lot of time. So if you want to start from where we are here, go to the description of the video and download the data set that we see. All right, so with all that out of the way, I know I can get a little long-winded on this, but I get a lot of questions and I try to answer them all in these videos. So the next step in this process for me is going to be to take this shape and start to add some of these extra details, like these flat spots. So for example, there's a flat spot behind where the inlet is to the airbox. There's a flat spot right here. There's a flat spot over on this corner. And this is going to be the first thing that we want to do before we ever go in and start to add more details. Now, because I don't have this part and I don't have this car, unfortunately, I love MR2s and it'd be really cool to have one. I don't, unfortunately. So I only have the scan data. This is what I'm looking at. So for me, oftentimes I have to turn the edges off, which is Control and 4, and kind of look around the part without the edges, because sometimes this will reveal things that are a bit harder to see when we're just kind of dealing with all those triangles that we're looking at. So what we can see is on the inside, we've got this sort of flat spot section. There are some lipped features here Sometimes you'll find that this is an extra filter element. It could be like a suppression screen or some sort of extra feature. I would guess that these corners right here are actually squared. This is probably a pretty big T. This section here is likely added for ejectors, so it likely carries all the way down, and so that way there's a spot for this to get pressed out of a mold essentially. And there are additional features like these things at the bottom, again, likely for some sort of extra filtering or suppression screen or something that happens. This section over here, likely, again, a bit of maybe baffling. I don't have the other side of this airbox, so I don't know. But we are going to try to add all of these. The areas like this where basically we've got a bunch of triangles, this is likely due to trouble getting actually into those areas to scan. Because that's such a deep pocket, scanners have a hard time looking down into there. So it's obscured by the rest of the geometry. We see the same thing on the inside here. So, these areas are kind of obscured. So we just have to use our best guess, especially when we don't have it in front of us. If you do have the object in front of you that you scanned, that obviously makes it quite a lot easier because you can measure things and kind of dive in a bit deeper. But for right now, we're just going to make some assumptions here. So as I look at this, I want to start by creating these flat spots. Now remember, ours is still a solid body. We talked about shelling it, and basically that's something that we're going to do a little bit later. We don't want to get into the process of creating a thin-walled body until all of the external features like these indents and recesses are done. Otherwise, it's just going to be much harder to work with. Now, I've done plenty of designs where I've had to do these things after I have a thin part, just because where things fall in the timeline. And it just takes a lot of extra work. It's not something that you want to do if you don't have to. So how do we go about this process with all that? Well, it's tricky because we don't really have a good way to get a cross section. Like in this area, there might be one spot where we can actually get that cross section. That works okay. This one is likely okay. We could maybe pick up on it right here and just extrapolate. We're going to add these bosses after the fact. And the one on the back corner, this is okay because this is probably just a large hose that clips in there. We can see enough of it that we can make that distinction. All right, so this is a case where we've got enough information that we can do it a couple of different ways. First way we're going to do it is we're going to do a mesh section sketch. So we're going to select the mesh body. Again, it's unselectable, so we got to grab it over here. We need to select the plane. I'm going to use this as my plane. And then I want to drag it until I get to right there. So basically it looks like 40 millimeters. And what this is going to allow me to do is pick up on that flat section. Now, if it's a little too close here, you can probably pull it back a millimeter or two just to make sure that we've got as much as we want. There's a fillet in that corner or rounded section. So if we want to pull it back just a little bit more, we're going to say okay. So that'll give me that. I'm going to repeat this process and just do all the mesh section sketches now. So again, select the airbox. It's unselectable, so I need to select it in the browser. And then I'm going to pull this forward until I get that flat spot. So that looks pretty good. Again, this is going to be 3D printed, so any variation in, let's say, airbox volume that we're going to have by being a millimeter off in the corner here, it's not really going to matter. Now, the one on the back side, this is a little bit trickier, but if we look at it from the top, again, this is drafted because it's a molded part, but if we look down at it from the top, it's essentially a cut through the corner. So if we want to do this with a mesh section sketch, we can. I'm just going to eyeball it, and I'm going to work through just creating a sketch on the top plane, and then we'll use the extrude offset options to deal with it. So for that one, I'm just going to go kind of an eyeball method, which we could do with all of these other ones as well, but I wanted to show both methods. That way we could have a good understanding. Now, the third way that we could do this, if you really wanted to, is to go into something like the Forms tools. And for example, let's go ahead and do Face with Object Snap. And what I'm going to do is just grab here and create a face right there. You can see it's relatively close. There's a little bit of curvature there. But then what I can do is then I can extend all the edges out on the surface, and then I can essentially create a plane in that area where I want it to cut, and then I would repeat the process by building the surface by trimming it. So for example, we might create a sketch here, and then I'll use my line tool to create a cut in that area, and then I can use that as a trim to get rid of this. In most cases, when you're going through a process like this with surfaces, and maybe we do a ruled surface on this corner, turn off chain selection, and we pull that forward. So if you're using a process like this with a ruled surface, so if we hide the mesh and we bring back the solid body, we can build out these cuts and recesses in this way, and it's fine. Generally, with more planar cuts like we have here, it's not worth the effort. The main reason that I would do this is if any of those cuts were going to be more organic in nature. They seem to be pretty planar for the most part. So if they're more organic in nature, then I might come back and use some of these freeform tools to do it. In our case, I don't think it's worth it, but that is a third valid option. So I'm going to delete all that stuff because I don't need it. All right, so let's focus on this one first. So what we're going to do is right-click and edit the sketch. I'm going to hide the mesh body because I don't really need to see it right now. And then for my sketch tools, I'm going to fit curves to a mesh section sketch. And I'm just going to create a straight line from here. And then I'm going to redo the selection. So basically what we're going to do is we're going to clear out of that. So that'll leave the line behind. You can see there's a little bit of curve variation. Could be the fact that it's not truly planar. It could be deformed from use or the molding process or something like that. The next thing I have here is this little section where we want to build a straight line. It's really only got one triangle, so we only have two spots there that we can actually click on. And I'm going to say OK. Now, in the last video, I had a comment come in about using the extend tool. Now, typically, I was just manually extending these out. The extend tool in Fusion actually works pretty well because it will go down to the projected intersection between these two edges. So it is a great option. So if you do have it, then use it. Over here, because there's no line over here for it to extend to, we don't have anything. So what I would say in those cases, I'm going to hit escape. What I would say in those cases is you can just make a line out in space. Let's say we'll make one up here as well. And then you could use the extend tool just to extend it out all the way. I want to go that way and then hit escape to get off the tool. So those are just kind of temporary sacrificial lines so that it extends out far enough. But that is a perfectly valid option, and it was a great point by the person that made that comment. All right, so now that we have this, we have to make a decision on the next tool that we want to use. So we've got options where we could create a surface, extrude, and then split the body. In reality, based on the geometry, it's probably easier if we just finish this off. So I'm going to hover over that point, get that extension right there, and then just turn this into a closed profile. This will allow me to create an extrude, and we'll go to our solid tools, extrude, and basically we need to figure out where it goes to. So what I'm going to do is make this go two directions, two sides. And so over here, remember, we're going to have some fillets and things that are going to happen. And I'm not going to subtract this just yet, and I'll show you why in just a moment. And then this one, I'm going to pull out this way and maybe take it to there. And we're going to say OK. So the reason that I decided to not use it as a cut tool just yet is because in many cases, you'll find in all sorts of designs, in many cases, you may actually need to do some adjustment to the shape. And sometimes it's easier to do as a solid body on its own and then subtract it later. Sometimes it's perfectly fine to do it after the fact. But so for example, if we wanted to account for some of this draft, so I could take this bottom face and use move copy. I'm going to reset the pivot point. I want to put it on this back edge. Just you can click anywhere on the edge. It'll be fine. And then I'm going to rotate this around a little bit. And then I'm going to rotate that face. So, if we needed 10 degrees of draft, we could use the draft tool, of course. But if we needed 10 degrees of draft, we could rotate the face and now it's it's a little bit closer to what we have. And then we may need to go ahead and round these bottom corners. So we use the fillet tool, F on the keyboard. I generally will start with 1. So if I look here, it looks to be about 4 millimeters. And then I'll come over here, hold down Control, and find the other edge. It's hard because we don't actually know what's behind this. Again, because the scanner filled in this area, or the meshing process did. Or just potentially there is no corner there because the geometry gets filled in with these little clip features. So I just have to assume that it's the same as this side. So I'm going to say OK. And now if I hide the mesh and show this, I've got a body that I can use to remove from the rest of this. So we're going to use Combine. We use Cut, Main Body, remove this piece, and say OK. Now you might be thinking, why didn't I also round these corners off? Well, in some cases, it might be easier, more beneficial to do it on that solid body beforehand. In other cases, you might find that coming back after the fact, when you can actually see the mesh here, and pulling this up until it loosely matches, let's say right there, you might find that that's easier. So it just kind of depends. It's per case basis. Sometimes it's easier to do on the start of it with that solid body. Sometimes it's easier to do after. Now, this isn't going to be perfect, right? Again, we're doing this for 3D printing. We probably didn't even need to make this flat spot. This is likely done simply based on the fact that it was injection molded, and there needed to be some sort of feature on the inside where they could, they could mold up to this wall. You can see there's a draft on this wall. We can see the whole thing. And likely that flat spot was partially due to having a good shutoff surface to create that feature. So it's very likely that we don't even need to do it for 3D printing. But again, in the interest of trying to preserve the internal volume of this thing, we're going to get it as close as we can. Next, we've got this sketch. We're going to do a very similar process. We're going to edit the sketch. We're going to use fit curves. And once again, I'm just going to pick 2 points here on the straight section. We'll say OK. Now, if we bring the mesh back, this straight section should cut all the way through the body. We shouldn't need to have a piece come out forward, and it should cut all the way through the top. So it's going to be slightly different than we did on the other one. But what I'm going to do again is I'm going to use their sort of sacrificial lines. And I don't want it to go all the way down to the lip there, but I do want it to extend. So we'll just extend it out in both directions and hit escape, and then we'll get rid of that. So with this one, just based on the interest of exploring all the different options we have, I'm going to do this one as a surface. I typically would do this as a solid extrude like we did the first one, but again, just so that we've got the knowledge on how to do this, I'm going to go ahead and do it the other way. So essentially what we want to do is we want to look at the mesh and see where this starts. Now it has this sort of funky curve to it, likely based on the fact that this is rounded here, and that's just the way that the fillets and everything blend together. I'm not going to worry too much about how it gets narrowed down here and wider up here. If you want to take care of that, we can explore it a little bit, but I don't really think it's that important. So what I'm going to do is go to my surface tools, extrude. I'm going to pull it out this way. We're going to do 2 sides again. And generally, so you know what, while I'm looking at this, let's go ahead and let's just make it this sort of funky moon shape. So what I'm going to do is pull it past where I need it to go, and then we're going to cut it back. So let's go to right there, and we'll say, OK. All right, so if I hide the mesh and bring back the solid body, you can see that here, it hasn't gone all the way to this feature yet. Now, I didn't round this off intentionally just yet. We can always go back to this extrude and extend it out. But one thing you're going to notice is that it's now going to be kind of cutting some geometry off down here. Now, if we look at this, I'm going to use Control and 4 to hide the edges. It's not real apparent exactly where that cut is hitting, but the mesh does appear to be a little bit higher in this area, which means that our curve is likely slightly off. Now, the way that I would approach this is I'm just going to show the sketch, And from my side view, start to pull the bottom out a little bit. Now, I know I'm getting further and further away from the original, but again, it's important that we understand that the continuity of the geometry and the intent here is 3D printing. I don't need it to be perfect. I want it to be close. And I'm going to do Control and 6 to bring my edges back, bring the solid body back. And you can see that it's still cutting outside of this, which means that the fillet may be better off if we do the fillet beforehand, before we actually cut that out. I'm going to hide the mesh section sketch because it's just kind of in the way. The next thing that we need to do is we need to trim this so that it matches that sort of funky shape. So hide the solid body and we'll create a sketch. This is planar because we made it from a straight line, so we can create a sketch directly on it. And basically what we want to do is create a cut that matches that shape. Now, this is probably going to be a simple arc, say like that. That'll be close enough. Hide the mesh. Trim tool. This is our trim tool. That's the area we want to get rid of. And then we'll hide that sketch. And so the reason for this is because now what we can do is on our solid body, this stuff needs to come forward. So if we do, say, a ruled surface from all three of these edges, it'll be better for continuity if we do that. We can bring that forward. We've only got new body options, so you'll have to go back and stitch these back together. So now we've got this tool that we can use to essentially cut away geometry. We also created, inadvertently, we've created a plane that we can use for some of these additional features. So the plane is going to help us be able to create these bosses. We don't need to create another construction plane. We can just use this surface after we cut the solid body. So this brings us to our next point. How do we deal with the fact that it's going to be cutting away this edge? So I'm going to start by trying to apply a fillet here. Now, as we begin to pull this down, I'm going to use 4 millimeters like we did on the other section. Now, you might be thinking, okay, well, is that going to match the mesh body? Well, no, probably not. But I am more concerned at this point with making sure that the geometry is clean and continuous. Again, minor differences or nuances in the shape isn't going to matter for 3D printing or injection molding really, but making sure that we've got nice clean edges is going to be more important. So I'm going to say okay, and now I want to move this entire thing out just enough so that it clears that fillet. So back in the sketch that we created here, I can pull it forward until it clears that fillet. So once it clears that fillet, now I'm not going to worry about the cut or the split body being kind of in the middle of the fillet here. So I can use my split body tool, select the body we want to split, and the splitting tool is going to be this entire surface, and say, okay, we're not going to extend it out because basically what we want to do is get rid of that little piece. Now here's where things are going to get sort of funky because we've got a bunch of straight edges and areas that need fillets. So I'm going to start rounding these edges off. So F for fillet, I'm going to start there and down here, start to pull this out, and you can see that it's giving me an error. That's because there's not enough room. Let's try something small like 5 millimeters. There's not enough room because when you start to drag that arrow at a funky angle, sometimes you can very quickly and easily get to a large fillet. So with those small ones added, I'm going to start to add a fillet here. You can see that we get to a point where it's making faces disappear, and right around 1 millimeter, it fails. So if I go down to 0.75, it's okay there. That's a pretty small fillet, and that's likely not going to be a great representation. So if you run into this, what I would say is delete that last fillet, roll back to our surface, because remember our surface is quite a bit larger, and then add the fillet, whatever size you want here, because we can add quite a large fillet, 43 millimeters. And then when we go through and do our split body, we are now able to split the body with those rounded corners. So this means that we don't have that small triangular face here. So if I try to add a fillet, now I can go bigger than that 1 millimeter. You can see it's also running into an issue when it gets too large and that face starts to disappear. And again, we can go back to the same thing. So we'll go back before the split body, and then we can add our fillet to this corner before we ever remove it. Now, the size of this, typically what you would do is you'd go back and take a look at what we have here. You can see that this is, in reality, this is a relatively small fillet. So I'm doing all this extra work and I don't need to. But again, the important thing for me is that you understand all these little nuances and different approaches to the order of these features, where sometimes it makes sense to, add a fillet, even if it's a 1mm fillet, it makes sense to add it here before we do our split body. In some cases, it might make sense to add it after the fact. This is probably the corner that's the most important. I'm going to go ahead and make this 4mm, and that should automatically get it to match up pretty well with the rest of this geometry. There is going to be an area here where these corners sort of come together. In some cases, depending on your own geometry, you may be able to switch between rolling ball and setback if you've got 3 corners coming together. For our purposes, this is going to be fine. But if you want to address this, or you want to, make it a little nicer, we can talk about how to do that. So essentially what I would do is start a sketch on this, this sort of front, this is left, but front looking at the airbox. And basically what I want to do is I'm going to project. So select these 2 edges. You can use P on the keyboard. And basically what I want to do is I'm going to take a spline directly between those. You can also use something like blend curve. So for example, if we want to go from this curve to that curve, that's another nice shortcut that we can do with the blend curve. But essentially either a spline or a blend curve, a spline with tangency, blend curve will do it for you. And we're going to finish the sketch and we're going to use split face. So we're going to split these 2 faces with this tool, and then move over to our surface tools. I'm going to select and delete, by hitting delete on the keyboard, all those faces. And then we're going to patch this up. So I'm going to group all the edges together. I'm going to make sure they're all tangent. You can also play around with curvature continuity to see if that gives you a better result. Because the fillets themselves were defined with tangency, tangent is probably a good option. And then we'll stitch this back together. It'll automatically turn it back into a solid body. So again, is that needed? No, it's probably overkill. The printing this with that fillet would have been totally fine. There are more nuances, like in this case, changing this to a curvature continuous fillet instead of tangency or something like that. But I'm not going to go too deep down this, as these videos already take quite a long time. But if you need to do this manually, that's a good way that we can do that. If we hide the edges, that should look okay. I say okay because in my opinion, the surfacing tools in Fusion do have some limitations. So a tool like Plasticity and Xderbs would have patched this up with a higher quality surface than Fusion will. But if you're going to go about this process and you want to kind of play around with that, then you can. For our purposes, I am actually going to get rid of that and just leave the original fillet. I may regret that later when we go to do a shell on this, but for right now, that's what I'm going to do. All right, so I'm going to save this. We've done this for about 30 minutes now, but I want to save that so that we don't lose any of that work. And I want to try to shell this. I'm going to say 3mm and just make sure that everything does shell properly. We did have a small fillet, so we had 1mm fillet there on this inside corner right here. And it's just nice to just double check and make sure that at each stage of the process, when you start to create these big features, that you are still able to turn this into a thin-walled body. Probably one of the more common questions I get around freeform or surface modeling is the inability to thicken the part, or the inability to create a shell or a thin-walled version of it. It generally will stem from corners, whether complex surfacing or manually patching these fillets or something like that. But if you, each step of the way, if you do like a test thicken or a test shell, that'll help you identify when those problems are presenting themselves. All right, so now that we've saved this, a couple of other things that we can do in this video is we can deal with that back corner, and then we'll likely go ahead and add some of these features. I don't want to do everything in this video because I don't really want them to be hours long, but I do want to make sure that we are making progress on it. So this little extra piece we don't need, I'm going to right click and remove it. And then I want to create that feature. All right, so I mentioned we could do this with a mesh section sketch. It would be relatively easy. I'm going to do it sort of a more manual way. And by a more manual way is basically what I want to do is I'm going to just create a line that is roughly right. Now remember, if we leave these underdefined, then we can always come back and adjust them. But basically what I'm trying to do is match that shape. And then using the line tool, I'm just going to finish this off. So create that triangle. Now, you'll notice in a lot of these, I'm not using dimensions at all. In a lot of cases, parametric modeling is great. And depending on what you're modeling, you 100% need to add dimensions and fully define your sketches. For stuff like this, if we want to come back and tweak this corner or adjust the cut, having it underdefined, as long as the sketch isn't visible and you're not actively grabbing and moving stuff around, you're not going to cause any problems. So it's just kind of like a hybrid between direct modeling, but still having a defined sketch. So a lot of times I'll just leave things underdefined like this. If this is like a one-off design, it's going to be 3D printed. It's not like a production part that's going to injection molding. I don't worry as much about those nuanced details. All right, so we're going to extrude this. One thing I wish Fusion would do better is I wish when you change the start to offset that you could just drag it up. What we have to do is we have to start to manually try to find how high up that cut is. Now it looks to be about 30 millimeters. Let's go a bit higher. And so you can see it's probably about 30 millimeters. And I'm going to say, okay. So what we have now is a cut. You can see that because it's drafted, it's gapped off the top a little bit more. I'm not worried about that, but again, we could use things like move face if we wanted to. And again, to do that, when you select a face, automatically when you start move copy, it'll be set to that. But if you invoke the command, you'll need to manually select face. Then you'll need to set the pivot point. In this case, we want to put it on the bottom edge. And then you can come back, rotate this around till a good view, and then you can rotate that. For a large part like this, it's probably between 3 and 5 degrees for most of the external draft. Small features might be 1 degree, but this is probably somewhere between 3 and 5 degrees. All right, so now we've got our airbox. We're going to remove this piece from it, and then we'll bring the mesh back. We'll use our fillet tool. I'm going to start down here at the root, get it pretty close. And again, what I'm looking for is when I can see the mesh popping through, and it's kind of about 50% of that face. I'm going to say, okay. And I'm going to do another fillet and round off these edges here. Again, you can see it's jumping up to like 75, 50 millimeters pretty quickly. It's obviously not that big. 7.5 looks to be okay. And if we hide the mesh, you can see now we've got those faces. So so far this looks pretty good. Let's go ahead and save it. The next thing that we want to start to think about is going to be when features get added relative to creating a thin-walled part. So the inlet here that's going to the airbox is thinner than the rest of the design. So adding this feature now and then doing a shell or a shelled or thin wall feature is not ideal because they're different thicknesses. The main body is roughly 3 millimeters. This looks to be a bit thinner at 2, maybe less. So I don't think it makes sense to add this until after we've already created that thin wall shell. The other features that you might consider adding now, let's hide the solid body, would be things like structural elements, like these chamfers. Those could be helpful to add at this stage if you didn't need this flat surface to hold the filter element. Now, again, I don't have the bottom piece of this, but just having worked on hundreds of, not more than that, cars, I know that there is going to be a filter element that gets clamped down here, and likely that surface is going to be critical. So again, that's when I look at these things and I say, okay, well, that's going to get added after the shell. These clamping pieces, they're going to get added after the shell because we don't want it to create a pocket on the inside. All the ribbing on the inside gets added afterwards, obviously. So I think at this point, we're actually to the stage where we can go ahead and we can shell this thing to make it a thin wall part. And that's probably where we'll end this video. And the next one, we'll start to add all these little tabs and features. So let's go ahead and select this. We're going to select shell. But again, I'm going to hold down, I'm going to turn off tangent chain. And then I want to add these additional back faces here. All the way to those fillets. And then we'll say 3 millimeters. And the reason that we're doing this, we'll say, okay, the reason that we're doing this is because the real part has these tabs, and basically it's opened up to that side, whether there's an extra section of the filter element that hangs out, or making it easier to just open the Airbox slightly and slide a filter in. I'm not really sure, but it is open on this side. So having the ability to do that is definitely helpful. Now, does this little bit of a distance here matter for us? Maybe not. Again, I don't know without having the real part. You can modify the shell, hold down Control, and you can remove, let's say, that face. And then we can do the same thing over here. Hold down Control, remove that face. And then we can use tools like Press Pull, which is Q on the keyboard, and we can pull this back. I'm going to change this to new offset because that way it won't affect the rest of the stuff. And you can see I can kind of pull it back to roughly there, 4 millimeters. I'm going to hold down Control and add this one to it. And that'll get you a bit closer to that final shape. We can round things off, obviously add fillets and so on. But for the most part, just playing around with your different options on how to cut that. We could also omit those faces from the shell and then create a sketch and just cut away what we don't want. So for example, if these edges needed to end in that sort of normal or perpendicular fashion, which is not how it works here, then what we could do is get rid of the press pull. We can create a sketch. And basically what I'm going to do is I'm going to find where that edge is. So I'm going to use my line tool, and I'm just going to come straight through, making a vertical line. And I'll just, again, not really using any dimensions, just turn that into a closed profile. So now if we take this entire thing, and I'll hold down Control to select both profiles, E to extrude, pull it up this direction, and then say through all. Also hold down that, say through all. Why is it not cutting? All right, I'm just going to manually pull it up. For some reason, through all preview is not working. Now what we've done is we've cut that off in sort of a planar way. It's not perfect. Again, if without having the actual physical part, we just kind of have to make some decisions. But you can do things like add small fillets here, or we can, make the cut so that this is a straight line. That's possible. It just looks like the fillet that I chose on the outside is maybe a little bit large for that corner. So for the purposes of what we're doing here, I'm not too concerned about it. But again, these are things that you would have to make the decision on when you're designing these parts. So I'm going to come over here, hold down Control, and we'll add that as well. And I'm going to call that close enough for our purposes. All right, so we're making some good progress. We're about 40 minutes in. So the first video was, I think it was 45 minutes. I don't remember. This one's about 40. In reality, without narrating this, we could be done by now, obviously. But there's not too much left to do. Adding these features like the inlet, the mounting points for what I assume is mass airflow sensor, and some of these other mounts that, I don't instantly know what they're for. This looks to be some sort of probably a clip, either for wiring to the mass airflow sensor or, who knows what it is. But we just have a couple of extra things to do and then make some decisions about the support that we want in this bottom corner. Because again, these thin ribs, those are injection molded style features. We can get around that by creating just a large chamfer in that corner, and then we can use infill, past a certain thickness, past 3 millimeters, we could say do infill or whatever the case might be. But hopefully you're finding this helpful. If you like this type of long content, doing these types of parts, then leave a comment, let me know. I've already seen a few comments about doing more car parts in quick surface, both in light and pro. I also have some quick surface for SolidWorks content planned. We will get to that. Unfortunately, just not enough hours in the day to make this all happen. But after we finish this part, we can talk about another part which we'll do in quick surface, and we can also circle back on this part so we can identify some of the different ways that we would do it. I would approach it largely the same in quick surface as I would here. We just have a better ability to know how far off we are from the original part with the analysis tools, and we can quickly generate things like primitives for these cylindrical features. This could be done with just a couple of clicks, and that makes that really easy without having to create a construction plane and a sketch and features and so on. So there are just ways that we can speed up the process a bit more in quick surface than we can here in Fusion. But I think we're getting pretty close. There's not too much left to do. We'll definitely be able to finish this up in the third episode. But if you haven't subscribed already and you want to follow along with content like this, please consider subscribing. And if you have any questions or comments, leave them on the video. As always, thanks for watching, and we'll see you in the next one.